Okay, this one we're going to take a look at the isosceles triangle theorem. All right, here we go. Isosceles triangle theorem. So this one we're going to construct a triangle, ABC, and we're going to use line segment AB is 6 centimeters, and AC is equal to 6 centimeters. There's my isosceles. Now, I am going to say the base, okay, because you don't necessarily need the base, but I'm going to just say for the sake of argument that the bottom of my triangle, so if A is the top, right, that's my A, so from A to B is going to be 6, and from A to C is going to be 6. Let's say the bottom, which is just going to be the BC, is 4. Now, I don't really even need that because I'm not even that concerned about the base of the line segment. I don't even really need that. In fact, let's just kind of leave this off and let's just make two lines that are 6 centimeters. All right, so starting with A, because it's A to B and A to C. So notice the first letter of my two line segments is A. That means they're starting in the same location. All right, so 6, and I'm just going to draw. Boop. And then I'm going to come over here and I'm going to draw another 6. I don't care how wide I make it. You can make it as wide as you want. I'm going to make it tall and kind of straight up. So I'm just going to make another 6 centimeter line. Okay, so A to B is 6 centimeters. Notice I'm labeling. A to C is 6 centimeters. This is like the one we did in class. Now, the bottom, the base for BC, I think is 4. Yep, pretty close. Okay, so look at that. That's 4. That's what I estimated it would be. This is the one we used in our practice. Okay, so I've just constructed an isosceles triangle. I know it's an isosceles triangle because the sides are equivalent. They're the same. These are congruent. Now, according to the isosceles triangle theorem, if I constructed an isosceles triangle, angle B and angle C should be the exact same. Now, again, I drew this by hand. It's probably off a little couple degrees, but according to the theorem, the base angles are going to be congruent. So angle B is going to be congruent to angle C, and that's according to this theorem. As long as the opposite sides are congruent, okay, the opposite sides are congruent, the base angles are also going to be congruent. Okay, so let's test it out and see if we were correct. I'm going to erase just this little bit here. I'm going to erase, and then I'm going to measure. All right, get that protractor out. All right, so here we go. So when you're measuring paper, unlike the digital version where you can shrink the protractor, you can't shrink the protractor. So sometimes you need to give your line segment a little bit of a line off the triangle. So I'm going to see where B ends. I'm just going to kind of extend it, and I'm just going to make sure it's straight as possible. See how I kind of did that faint line? That's because I need to measure this angle C, and I need more. I need a leg. See how I need it to kind of so I can see the protractor here. Okay, so I'm measuring angle C, so my dot needs to go on C. I want to make sure it's super straight, as straight as I can make it. Okay, now this one looks like it's going to be in between 70 and 80, so 75. Again, it looks like it's off a degree, so maybe 74, 74, 75. Okay, so I'm just going to rate 75 because that's the closest degree. But it was a little off from that, a little under. You can, if you want to put 74. Okay, let's see if this angle is the same. So I have to rotate my paper around, and now I need to measure this angle. Okay, now look, I can shoot this leg up. I can add to it. You just got to be super careful to make sure you go straight. See that? You want to extend this line up a little. See, I just took it up a little, but I used a straight edge. Do not freehand draw that because it's going to throw your angle off a couple degrees. Okay. Put my center of my protractor on B because that's what I'm labeling, and I'm going to line that up so it's nice and straight. Okay, so right away noticing that I have a little bit of a problem. You can see that my construction is not perfect. My angle is off, but only by a couple degrees. So you can see, remember we said this one was 74? This one's about 72. Now I can tell you exactly where I made my mistake. If you notice my point, see how this one's up a little? I really should have this a little straighter. I can already see where I made my mistake. If I want to connect C to A, do you see how that's off? Even just a little tiny bit. That's causing my angle to be off a little in my measurement. Okay? See that? So that's why this angle is a little bit too big. Again, constructing this by hand, it's easy to make a mistake. So this angle is probably a little closer to 72 now. Let me double check. I'm going to double check it. And this time I'm going to go in this direction. Okay, let's see. All right, C, put my center on C. Make sure it's lined up perfectly straight. Okay, much better. Do you see that? Just that a little tiny adjustment. I was off just a couple degrees here, and that threw my line segment off, but now you can see it really is 72. See that? Okay, 72. So, I'm more accurate. I went and fixed it. Now I can show you that both of these angles are 72. Okay, now if you're constructing this by hand and you measure these two angles and you do what I did and you notice, oh my goodness, they're off a little bit, check your top of your point, the top of your pyramid here, because it could be off a little. Now, the other really cool thing about the isosceles triangle theorem is that when you're working with an isosceles triangle, you're actually using that perpendicular bisector or the angle bisector. So remember back in Unit 1 when we figured out how to make an angle bisector? I'm not going to construct that in this video. I'm just going to estimate here. But if I find the midpoint between B and C, which should be 4, right? I mean 2, right? If I measure and just find the midpoint, okay? That's just an easy way to make a bisector. I'm just taking line segment BC, and because it's an even number, it worked out kind of nicely. It's 2 on either side. Then I can connect A and the midpoint of BC, and I just made a perpendicular bisector. This is going to get into what we're going to talk about next class. So what I have just done is I've just constructed 2 triangles that are literally the flip of the other. And that's how another way you can prove that isosceles triangle theorem, because if I were to cut this angle A, in half and make an angle bisector, or make a perpendicular bisector here with my BC, what I'll have is angle B will reflect over on top of angle C, and those two 72s are going to line up, and line segment AB is going to reflect over top of AC, and those 6 centimeters are going to line up. So you got yourself 2 congruent triangles that you created with one isosceles triangle, and that's how you can prove the theorem works. It's awesome. All right, enjoy.